Subscribe to this YouTube channel by clicking the subscription button below. For future webinars and online short courses, please visit our website at australianwaterschool.com.au. Welcome to this Australian Water School webinar. This webinar series aims to bring you the brilliant, innovative thinking pouring out of the global water sector. Today we'll look at the very important issue of water security, the legitimate place of desalination and water recycling in ensuring water security. My name is Trevor Pillar. I'm the National Partnerships Manager here at IceWarm and the chair of the webinar today. But, you know, this is all about you, and you all are spread across the globe. Thank you everyone for joining, and there are hundreds. It's great to see you, and we look forward to a great discussion. We got lots of training coming up, as you can see there. I won't go into each one. Go onto our website or on our Twitter feed, and you'll see the details for all that. And there's lots more behind where that is. Still lots more than that coming up, but we'll go into that more later maybe. We are so delighted to have Neil Palmer, well-respected water engineer from Tonkin Consulting and many other places. Good to see you there, Neil. Neil has spent 43 years in the Australian water industry. I'll just pick up some of these things here. Fiji, Water Supply Department, the EPA, Tonkin Consulting, where he is currently, Australian editor for the international think tank Global Water Intelligence. Neil brings 4 decades of water industry experience, couldn't have this better, in government and private, and was voted #1 in water and wastewater international survey of 25 world water industry leaders. Pretty big effort, Neil. You don't look worn on at all. You look pretty settled about it all. And you're coming to us from the fair city of
Sydney.
That's great. It's absolutely brilliant. And we're so pleased you could join us. The reach of webinars is huge, and there would be 20 or 30 different countries joining us today. So there it is, Neil. You've got a pretty big audience of people who are keen to hear what you have to say, and all I can say is let's get into this. Over to you, Neil. They're in your hands. Thank you.
Thank you very much. Thank you very much, Trevor, for the warm welcome, and thank you to everybody for joining and entering into this seminar. What I want to do is present a fairly simple view of water security and what it takes to provide water security from our experience in Australia, and I know it's common from other countries elsewhere. So how do we properly use facilities such as desalination and water recycling in ensuring water security? Now, there's a lot of nonsense talked about water security, desalination, and water recycling. So I'd like to try and cut through some of this and look at the facts. A couple of weeks ago, it became evident that there was a paper published by Science of the Total Environment from researchers, Edwards et al., from the United Nations University in Canada. And it was basically an overview of the amount of brine that's produced from desalination plants. So they extract fresh water, they produce concentrate, it's generally returned to the ocean. It's been going on for 50, 60 years. The science and the ability to manage this without environmental impact is fairly well known. But look at the headlines that came up from Water Online. UN warns of rising levels of toxic brine. Nature Middle East, warning on desalination's risk to marine life. So this is a beat up by the media because desalination's mentioned. It's become a fairly common thing, which is a shame because it diverts us from facing up to the real benefits of desalination and water reuse, which I want to touch on. Now, what are the facts though? The Sydney Morning Herald in September published the findings of a very long peer-reviewed research project into the Sydney desalination plant. Now, this is fortunate because they had before, the desalination plants operated fairly seriously for 2 years and then it was mothballed. So you've got a before, during and after. And if you look inside the red circle there, the report was published in Water Research, showed that there was a negligible effect on the offshore ecosystems during the 2 years it was operating. Now this is pretty typical of desalination plants around, but it just shows how the media obtaining of certain amounts of information can lead to very much misleading public headlines. Now, I'm speaking to you from Sydney. I normally live in Adelaide, Australia. You can see in the graph there, this is the storage levels for Sydney, which have just dropped below 60%. And that's the storage point at which, in years gone by, water restrictions would have been announced. Now we have a desalination plant. It will produce about 15% of Sydney's water supply, and it will be started up and gradually ramped up over the next few months. And it won't be turned off until the storage is returned to 70%. So here is a clear example of water security. Remember, the desal plant produces about 15% of Sydney's water supply, which is quite significant. They have capacity in future to double this if it's needed. Now, it's commonly said that water is precious, don't waste a drop. But what really are the facts? 75% of the Earth's surface is water. There's plenty of water, but 90% is saline, so only 0.5% is freely available as fresh water, and that's not always where you need it. But fortunately, technology exists to convert impaired water, and that is brackish water, wastewater, seawater, into fresh water. Now, our first case study I'd like to talk about is Melbourne. That's Australia's second city. It's regarded as one of the world's most livable cities. But during the severe millennium drought that afflicted Australia for 13 years, from 1997 to 2010, it suffered very, very draconian and severe water restrictions, such as you couldn't water the gardens, you had to limit showers, you certainly couldn't wash your cars. Now, water storage performance was measured and published in a report called Melbourne's Water Future. The Vic Desal plant is a bit bigger than Sydney. It's 150 gigalitres a year, and it can produce about a third of Melbourne's water. But it was opened in 2012 after the drought had broken. So there are a couple of charts which showed what happened if there was no water restrictions. By 2009, Melbourne would have run out of water. So they introduced very draconian water restrictions, and they managed to keep the water supply until the rains fell. Now, this report didn't consider what would have happened had the desalination plant been available. So we crunched some figures, and this is the situation of the storage levels had the Victorian desalination plant been available during the period of the millennium drought. They could have sailed through it, and I'll repeat the words here, and they could have continued to enjoy life in one of the world's most livable cities without any water restrictions. Second case study is a small town called Penneshaw in South Australia. This is operated by the South Australian Water Corporation. It's a holiday village, so during winter time the population's about 200, but it grows to about 3,000 in summer. No reasonable water supply system can easily keep up with this. But they have a small seawater reverse osmosis plant. It's recently been upgraded to 400 kilolitres per day. But it's attached to a 30 megalitre lined and covered storage, which surprised the town. They can duplicate the storage in future if they need to, but the desalination plant operates at 100% capacity all year. The large storage balances the extreme peak demands. Now, one of the side benefits of this is that in operating plants, in my experience as an operator, means things break. And they break usually on a Friday afternoon when everybody's gone away for the weekend. With this arrangement in Penneshaw, you don't need to fix it until the next week. It takes the pressure off relying on mechanical plant and equipment and puts it back into the gravity storage system. Here's the Penneshaw desalination plant on Kangaroo Island, recently upgraded. Now I want to talk about a hypothetical. So if you're not near the sea, how do you ensure water security? Well, here's one way of thinking about it. Let's imagine we've got an inland Australian town of 10,000 people, an average annual water demand of 900 megalitres a year. It's got a 1.8 gigalitre reservoir, and the annual inflow is 1,000 megalitres per year. So in normal times, the town is fine. It can keep up with water, and this is what we see. The reservoir spills. Now, what happens if there's a 5-year drought? Let's say the average annual inflow drops to 500 megalitres per year. Well, if you don't have water restrictions and keep on using water, eventually you run out of water. Now, let's have another scenario where we recycle the wastewater from the town. It becomes highly treated, suitable for indirect potable reuse, and we recycle that back equivalent to 30% of demand. When we look at the chart now, you can see the water supplies become much, much more sustainable, and you can enter into a very long period of drought and still maintain water security. planned indirect potable reuse happens in Perth, Western Australia, through the groundwater replenishment scheme at Beanyup. The capacity is currently being doubled to 28 gigalitres per year. Now, this treats the water from the Beanyup wastewater plant through a reverse osmosis and advanced oxidation processes, is injected into the aquifer, and downstream is a groundwater treatment plant that pulls it out and supplies people. The Water Corporation did many years of public consultation to persuade people that this was okay, and it's been accepted. But we've had unplanned indirect potable reuse for years in the Murray-Darling Basin in Australia, in Europe, USA, Asia. So what's wrong with planned indirect potable reuse? Certainly something to think about. Now, as we work towards a conclusion, I've shown a picture of bananas. Now, we grow bananas in Australia, in Queensland, and occasionally there are cyclones that destroy the banana crop. Well, the response is not for the government to say, well, you can only eat one banana on Mondays, Wednesdays and Fridays, and the people across the street can eat a banana on Tuesdays, Thursdays and Saturdays. No, the price goes up because they're scarce. It's a common thing in the markets around the world. Now, I contend that water restrictions are archaic and draconian and have no place in a well-managed water supply. And I've tried to show that a small, steady, climate-independent water supply into an existing natural system greatly enhances water security, leading to what we call a climate-resilient water supply. Now, there are vast resources of impaired water available, as I mentioned before: seawater, brackish groundwater, industrial and domestic wastewater. But this water comes at a price. So how do we pay for water security? Now, I've shown a couple of illustrations here of inclined block tariff charging for water rating, such as used by the South Australian Water Corporation and the Water Corporation of Western Australia. So basically, you can see the inclined block tariff means as you use more water, the price goes up. Now, in drought, people use more water at a higher charge, and this provides the additional revenue to pay for water security. Consider the alternate scenario where you have draconian water restrictions. People buy less and less and less water. The fixed costs are pretty much the same, and so there's less and less water for the water authority to make a profit from which they can pay for things like water security. A lot of people travel around Australia in the outback on very rough roads. And you can travel around Australia in a cheap car, let's say a Toyota Corolla. They're cheap to buy, cheap to run, but it's very limited where you can take it. You can't take it in rocks, up mountains, over sandhills. So people normally buy a Toyota Land Cruiser. Now, this is much more expensive, but it means you can go anywhere, it's reliable, and you will always be safe in it. And so water supply is a bit the same. If you want a cheap water supply and every few years you have draconian water restrictions or you run out of water, okay, you can pay a cheap price for it. But if in a place like Australia where you like to have reliable services and you want a reliable climate resilient water supply, it costs a bit more. Now, the interesting thing in comparing these two graphs, if you look, there's not a huge amount of difference between them. In the South Australian one, it jumps up to a reasonably high tariff, $3.65 a kilolitre, after you've used 130 kilolitres. This is in a normal house. In Western Australia, it jumps to $4.40 per kilolitre, but once you've used 500 kilolitres. Now, the similarity is stark because Western Australia, Perth, derives half of its water from desalination, seawater desalination plants, and a reasonable amount more from water recycling. And this is a result of climate change over many years. Now, the inclined block tariffs means that there's enough water used in Western Australia so that they can pay for the facilities and people have water security, and there's a high level of acceptance of both desalination and potable water reuse in Perth, Western Australia. They also have water saving measures and they also have stormwater reuse, But the important things are that the facilities have been built and are affordable for a system that provides water security. So to finalise then, technology is available to safely convert water from impaired sources to fresh drinking water. Now, the most economical way to operate a desalination and water recycling facility is to size it appropriately and run it at full capacity 100% of the time. That's the most economical way. And of course, it must be done in conjunction with existing storages to cater for peak demand. And the treatment facilities for these things can be funded by setting a long-term charging strategy, which includes a premium for higher water use during dry periods. But that concludes my presentation. I hope some of the ideas stimulate some thinking about ways in which we can solve problems, provide customers with a good product that's reliable all of the time and which is affordable. Thanks, Trevor.
Fantastic, Neil. Very measured and very logical. Love the comparisons, desal versus reuse, city versus country versus a tourist location. I can't help thinking of the humorous line, we're running out of water, where does it run to? I mean, it doesn't go off to Mars or anything, does it? You know, we've still got it here on the Earth, we've just got to find it. But here's the serious one. Each afternoon in the wet season, a year's supply of Sydney's water, equivalent, gets dumped in the northwest of Australia from the evaporation off the Indian Ocean. I'm just saying that simply to say, desal, it happens all the time in very large amounts. Am I half right, Daniel?
Well, water isn't consumed, it's simply recycled. So in the sense, all water is recycled at the end of time.
Yeah.
So no, very true.
Yeah, so it's just a recycling. Look, let's go to the questions here. Craig Bagnall, fantastic talk, Neil. Challenges to desalination have historically raised very high energy use and climate change impacts as a key negative aspect. What's the latest knowledge on life cycle assessment desalination in context of energy use, climate change, and what's been the response to this from the desalination industry?
Oh, a couple of questions for this, Trevor, or responses.
Yeah.
The Australian desalination plants all source their power through offset agreements with renewable energy, wind, and in Western Australia, solar power. So that is an attempt, I think, to recognise the impact of energy consuming technology on water supply.
Right.
But balance it against the fact that it takes something like 3 kilowatt hours per kilolitre to desalinate seawater. To pump water from Perth to Kalgoorlie takes 9 kilowatt hours per kilolitre.
Right.
So in your household, it costs perhaps a certain amount of money if all your water does come from desalination. I think it's about 0.6 kilowatt hours per day. Yep. Compared to the average hot water service, which takes probably 6 kilowatt hours per day. It's a huge amount that's used. Right. And then the home air conditioners take even more energy. I think in peak periods, 40% of Perth's energy comes from cooling through air conditioners. So I guess you've got to balance, do you want to cool your home or is water important? And everything takes energy. One last metric made famous by Gary Crisp, very famous professional in the water industry, is that the Perth desalination plant, the first one they built, runs on 22 megawatts. One jumbo jet runs on 66 megawatts.
Right.
So there are 10,000 planes in the air at any one time. So the energy to put an airplane in the air far exceeds the energy. So what's more important, travel or water supply? Yeah. So I'll leave those thoughts with you in response to that.
Yeah, thanks. That's very good thoughts. Carla says, would you say the public is open to recycling and reuse, especially with respect to water quality?
Yes, a couple of comments. It was a proposal in Toowoomba back in the early parts of the millennium drought to recycle water. Yep. And there was a very vicious public debate on it. And there was a referendum, and the referendum was lost in the end, and they didn't proceed with the recycling scheme. Contrasting that, the Water Corporation did a lot of work to persuade people that water recycling is okay, like many site visits and demonstration plants and explanation of the science. and there's been public acceptance of it. So I think there's a process which takes members of the community so that they have a good understanding that it's not things like in Europe, water is recycled in rivers a number of times before they reach the sea, and technology is available to treat it. Probably the best example, though, Trevor, is Singapore with the new water proposal, where Singapore desalinates water and recycles water, and it goes back into the public water supply. This is called the new water system, and that was also very exhaustively discussed and canvassed with the public, with a lot of public acceptance. So if you try and foist it on people with no warning, they'll say no, but if they understand it, they'll say yes.
Well, most interesting you should say Singapore, because Carla is from Singapore, and thank you for that question. She's a PhD in the University of Newcastle, but she actually is from Singapore. Thanks very much, Carla. Another question here from Craig Jakubowski. Can Neil comment on the size of Victorian desal plant, given it's rarely run? What size plant should be running at 100% capacity right now?
That's a good question. I was at a presentation by the Honourable John Brumby, who was Premier at the time it was announced, and he was very critical of the water administrators because Melbourne would look like seriously depleting its water supplies. And he said, I thought Thomson Dam, which is the very big reservoir that does Victoria, was big enough to provide water security, and it hasn't. And I said, well, if you want water security, you'll need a desalination plant. So he said, well, how big does it have to be to make sure that we never have this situation again? And they told him 450 megalitres a day, a third. Now, this was at the height of the millennium drought, and therefore very large decisions were made, I think, for political reasons as much as for technical reasons. And I think had they had the chance to review it like the Water Corporation did over many years, it was a measured approach, and both the Water Corporation plants operated at 100%. So some smaller Vic desalination plant operating all the time could provide the same effect, because Thomson Dam, for instance, has a very large dam but a small catchment, so it rarely fills and rarely overflows. So that water you could keep in the bank, so to speak, and then pay your daily water dues with the desalination plant. But that's a historical thing. It's easy to look back in hindsight and criticise these decisions. But in the heat of battle, you know, with the potential of Melbourne, a city the size of Melbourne, had the drought gone on a few more years to be seriously short of water, you can't sit back and do nothing. So it's easy to criticise now in hindsight, but that was the basis for the decision. It will operate. It has operated for the last few years. It will operate again next year. Because Melbourne is facing a similar situation to Sydney.
Yep. There are about 10, 15, 20 questions here on the board at the moment, but Dr. John Radcliffe's also joined us. Thanks, John, for joining us, and welcome. A few comments or questions, John, from you.
Neil, you've commented on the importance of trying to build a system with 100%.
You're a bit soft, John. You're a bit soft. Just come a bit close to the microphone. Yeah, that's it. Yeah, that's it. Yeah. Go again.
Sorry, and Neil, you suggested that we should aim at 100% utilisation of the membrane plants, which is more or less what's achieved in Perth, I guess. But if we look around the country, we haven't had that. Now, in the case of Adelaide, there's not been that much demand, so they run theirs at 10% and rotate all around the membranes and run the whole thing, I think, full time for a few hours every month. Melbourne had theirs off for quite some years. Then they were given an order for desalinated water a couple of years ago, but it took them 9 months to reconnect all the electricity. Sydney has, I guess, just recently re-established a plant online, which hasn't been used for 7 years. Brisbane had the Western Corridor scheme, in which they cheerfully discarded all of the elements apparently out of the membrane system, so it would take them 1.5 years to re-establish its operation. Can you comment on, how we should have done these sort of things, and can you actually maintain a membrane plant when you're not using it full time, or is that really becoming very uneconomic, particularly with the amount of capital you've got tied up?
Thanks, John. You're dead right. There's a lot of capital tied up in desalination plants, and the point I was making is the most economical way of running a desalination plant is to run it somewhere near 100%. Anything less than that, the unit price goes up because you've got the financial cost. In Australia, I think in these plants, we've tended to explain the concept of paying for the desalination plant like an insurance premium. Now, Sydney residents would normally be facing water restrictions. Now, desalination's come on. So I think they're probably feeling as well, I'm glad we've got it there. Whereas for the last 7 years, it's been, well, it's a white elephant, will never be used. You're aware of the hydrogeological cycle. We sort of enter a period of apathy. And I think that's the key to resist that thought of just, well, it's rain, so we don't have to worry, we'll forget all about it. But actually to think, well, there will be cycles of drought and there will be cycles of flood in Australia. So how do we make sure that we've got enough water? Now, one of the things is not to draw down your water supply, but to supply the water from the desalination plant. This makes sense. So you've always got the water available in your storages for when you need it during periods of shortage or drought. The example I picked was about 30%. That's about the size of the Vic desalination plant. And it may well be that as Melbourne grows to 8 million, it operates all the time because there aren't any other water sources that are likely to be available. They will probably look at water recycling as well. So it was built in response to a crisis, but over the next 30 years, it will become just a normal part of Melbourne's infrastructure. Sydney may be the same. Brisbane, I know the folks at Queensland Urban Utilities are keen on getting some use out of their water recycling plant, and they're looking at possibilities of agricultural use for high-tech, where they can afford to pay for the water. They're certainly not happy to have the facilities sitting around doing nothing. But yes, we did pay. I think in the benefit of hindsight, once again, a decision could have been made for a smaller infrastructure, but to operate more of the time creates certainly a far more economical solution, but gives the same result.
If you would be available, could you stay online for a little longer then, John? That'd be great. All right, thank you. Yeah. One here from Fauzi in New Delhi. Fauzi is a professor in the Terry School of Advanced Studies in New Delhi. If India has a choice to make between interlinking rivers and a desalination plant to meet the water needs of the water-starved regions in the Western Ghats in India, what, according to you, is more viable and sustainable? That's the question.
A good question. Two countries I know have faced this issue. One was Spain, where there was a proposal to divert the Rio Ebro, which flows through Barcelona south in sort of like a snowy mountain scheme. The government changed, the new socialist government came in and they decided on a desalination program, and they regarded that as a more viable option in the long term. One problem with river flows is that if there are changes in the river flows, then that can seriously affect the climate resilience of it, whereas with a desalination plant, for instance, on seawater desalination, when you look out to sea, there's no shortage of water. You're always going to be able to produce water. The other one in China, where they diverted water from the Three Valleys scheme up towards Beijing, now I understand that it was pretty expensive. And they are now building a very large desalination plant in Tianjin because the cost of desalination is about the same as building and financing the channel system up from the south. So there's just a couple of examples. Now, the answer for India would depend on a fair bit of analysis and prediction of river flows. But if you're going to move river water long distances, that becomes expensive as well. I mentioned Perth to Kalgoorlie, 9 kilowatt hours per kilolitre. It generally has to be pumped, and suddenly you're up for energy costs as well. No simple answer to it, but I think there's some principles here that could be learnt from Spain and China in their case studies to inform the challenges facing India.
Yep, let's keep this going. Daniel Webber asks, can water reuse help in the Murray-Darling Basin given the high use of irrigation? It may make reuse more difficult.
The amount, if it's recycling through urban water,
right?
The urban water demand is very low compared to the irrigation water demand.
Right.
And usually, the recycled water from towns like Mildura, Shepparton, Wangaratta, Albury, Wodonga, Goulburn, Canberra don't make a whole lot of difference to the volumes that are used for irrigation. So yeah, it does help, but it's a little limited. Could I suggest, Trevor, that John's probably in a better position to comment on that, being a former chief of the CSIRO Land and Water?
Yep, stay with us, Taya. We'll come back to you. Stand by, Taya. John, over to you.
Well, I think the issue that Neil makes really is what is the population that is living in that Murray-Darling Basin, and what's the water being used for? Now, in terms of recycling, for example, the only city with any real significant recycling is in Canberra, and that's just used for agricultural purposes and amenity use around the place, and the surplus goes into the Molonglo and the Murrumbidgee and down the Murray, which I guess is an example of indirect potable, which Neil alluded to originally. The amount of water which is used for agriculture is becoming much more efficient in how it's being used. We hear a lot of talk about cotton growers, with many people not being very clear on how much water is used for grow some of these crops. And now with the rain in Queensland, we're seeing everybody wanting to start the Bradfield scheme again and pumping water down from North Queensland to Central Australia and down the Murray. Now, as Neil's pointed out, the cost of pumping water is a very major issue, let alone the capital cost of doing it. And let's face it, 1 kilolitre of water weighs a tonne. It's heavy stuff, and people don't really understand that. They think it runs downhill from north to south, and it doesn't. And as Neil also pointed out, the Western Australians went through a whole process of looking at taking water from the Ord down to Perth, and it was one of the least attractive things compared to towing up icebergs from Antarctica and all sorts of other improbable things.
Yeah.
So I don't think the issue of the amount of water used is that important. And you've also got the political issues. So in Melbourne, for example, a pipeline was built to connect the Goulburn to the Melbourne system. And then there was a whole lot of politics about, well, we better do that. We'll have to plug the pipe because that'll threaten the livelihood of a whole lot of fruit growers. But the reality was it rained, so the problem passed off. What I think we need to do is to have people actually understand the hydrological cycle, which Neil alluded to earlier, and where the water goes and how much of it is used for what purpose, how much is used by the environment. And that's all part of the current Murray-Darling Basin argument that's about to blow up again right now.
Yeah.
And I think communicating with the public for having a better awareness is really the basis of all this water management.
Yep. No, they're great comments, gentlemen, and wide-ranging too. We've got to keep moving here. Tia, you're next. Tia Yasmin, are you still there? There we go.
Hello.
Where are you from, Tia?
Neil Palmer, impressive research and the presentation.
Where are you from?
I'm from Canada, Manitoba.
Manitoba, Canada. Great. Yep. Go ahead. Yep.
I was just wondering if you have any research or comments on the global water balance. I'm working in this industry almost 20 years, and I have found that is another kind of governance issue to have the fresh water right for everybody. Development countries are paying more than they're supposed to have their own liter of water, whereas the developed country misuses the water for doing the industrial purposes, and all those like the surface water pollution is happening more in North America than other countries. What do you're thinking about that as a water right in a global context to have the water security?
Thank you for the question. I'm always reminded when you talk about rights that then means someone else has an obligation. So to have a right to fresh water, someone has to pay for it. So many of the schemes in my observation have struggled because there has been this notion that we must not charge too much for water. The water supply system then breaks down, and then private people come with water carts and they sell at extortionate prices to people. Better to have a system where it could be private sector or government sector, is charged with providing and making the system work, making sure people pay and everybody pays the same to cover the cost of operating the system. The best example I can think of that is the Manila Water Company. I was involved many years ago because United Utilities, an English country, had a small stake in the business, but it was basically owned by Filipinos who decided that they would provide water reliably to everybody, but they also collected the fees for the use of the water. And now it's a system where Manila Water Company contracts elsewhere around the world. It's been very successful. And that took over from the original Metropolitan Water Supply and Sewerage System, which just wasn't able to cope with the job. There's other examples where it hasn't gone so well, but that's one example where the people all were better off because everybody got water, but everybody paid for it. I don't, that fully answers your question, but I think there's a lot of work to be done on the governance and institutional arrangements.
Exactly. Yeah, that's I'm focusing. That's to have the water rights or water secured. Talking about the water security, we need to work on the governance rather than general public are just helpless, but all those politics are happening in the up with the politics. So my focus is the governance things with focus of women. Thank you. Thank you very much.
Good luck with it. Thank you.
Yes, thanks for your great question, Tia. That's been really great. Appreciate that. There's another question coming online now. I see it's coming in from a telephone. If you unmute, introduce yourself and let's hear.
Yeah, hi. Look, Lee McNichol, excuse me, from the Basin Sustainability Alliance.
No, that's good. Thank you for calling.
I had a bit of some technical problems getting my question into you online.
You're coming through loud and clear now anyway.
Yeah, I'm calling from up Roma in Queensland. Basin Sustainability Alliance is a landholder group that monitors and tries to influence the activities of the coal seam gas sector in this area. In Queensland, the mining sector and the coal seam gas sector has unlimited take from the Great Artesian Basin. Nobody else does. And currently they're extracting 65,000 megalitres a year, which is diverted to so-called beneficial use for irrigation. We would like to see it used more efficiently and more sustainably to supply the towns across the area, which predominantly rely on underground water. Neil, do you have any suggestions to our recalcitrant councils in the area?
A very good question, and one which is vital to survival and economic development of local communities. But the question always comes down for who pays. And I think the perception is that the gas companies are making substantial profits out of the activities in the area, and that perhaps their contribution might be a bit more focused and a bit more generous. I think that there were some mistakes made in the early stages where particularly some very high emotions have been charged by gas companies accessing farmers' properties. It's a very sensitive issue. And I think can only be overcome by a very substantial investment in public good by the companies involved. Now, I'm not involved. My brother works in the oil and gas industry and has some observations on it, but the gas benefits people around the world. If it's causing some issues locally, then it's reasonable to expect that some contribution is made. And certainly from a point of view of goodwill and public good from the companies who might feel that they have a social corporate responsibility would reap a pretty high dividend if Roma, for instance, could boast a very secure and good quality water supply sourced from this water, which in some respects is treated and then disposed of into rivers and creeks and not beneficially used. We don't have a lot of good fresh water, as I've said earlier on in my presentation, and effective use of this, I think, is a priority. I don't know if that helps the situation.
I mean, Roma has 50 underground bores, all dependent on the Great Artesian Basin, and they're in strife at the moment with the ongoing drought, lowering standing water levels.
Yes.
Nearby, a major coal seam gas company is using their water to irrigate rose grass because it's salt tolerant. They irrigate at 4,000 parts per million.
Yeah.
Now that water could be further RO'd to provide reliable water security for Roma and not overtax the Great Artesian Basin. At the moment, there's a double dip, and the outflow from this area well exceeds the inflow into this part of the Great Artesian Basin.
Yeah, I can see that's a very great worry. The hydrogeology, if they're pulling out water at 4,000 milligrams per litre, that's not particularly useful to you, but the technology exists to treat it to drinking water quality. It's fairly well known, it's fairly well priced, and as I've shown in places like Perth, they're producing desalinated water from the sea, which is more expensive than brackish water desalination. But overall, it's not impacting on the volumetric charges compared to, say, Adelaide, where a much smaller proportion comes from desalination. So it's interesting. I think there's a solution there, but I think the solution probably comes more from the political realm than the technical arguments. And so there is an election coming up, so maybe that's your opportunity.
So we're making plenty of noise about it. We just cannot afford to waste very valuable and limited water in this area, underground water. It's as a livestock producer, my dams are running dry.
Yeah,
and I'm totally dependent on underground water.
Yeah,
it's gold.
Yeah, absolutely. Thank you.
Yep, that's great. Any comments from yourself, John?
Well, of course, it also depends on the extent of the drawdown structures in these various water sources. If the 50 bores are all close together and they're all drawing down, then not surprising that there's a considerable problem. If the irrigated roads grass is in a remote location in relation to other people's drawdown, it's probably got its own cone of depression, but it's probably coping to maintain the water supply. Now, really, as Neil's pointed out, all of these things involve economics. I think our councillor from Roma is suggesting maybe we could put some constraints on the roads grass. He might also be suggesting we should be desalinating it, but then you've got to ship it some distance, and I don't know what the transport distance is that would be required after you've desalinated it, assuming you've got access to power resources of sufficient capacity. So you've got to model all this and the cost of it, and it needs to be done, I think, with a long-term view, not with a quick, short answer for next week, because by the time you get it done anyway, it might have rained, and it seems to be doing so in other parts of Queensland with a fair bit of vigour at the moment.
Yep. Look, we'll move on. We've got 10 minutes left, and we're never ever going to get through all these questions. Thanks everybody for your involvement and discussion. Sorry we can't get through them all. I'm just going through the ones you've upvoted and slowly but surely getting there. I see Dr. Pankaj Kumar in India is coming online.
I'm here, yeah.
Yep, we got it. No problem at all. Yep, speak away. Nice to have you. So, from where are you from?
I'm from Bangalore, India.
Bangalore, yeah, okay. Yep.
More than 10 years, Bangalore has installed more than 200 MLD capacity of recycling of urban wastewater.
Yep.
More than 10 years period. And right now I am transaction advisor to Gujarat, another state where in 15 cities we are developing water recycling facilities. In my experience, I am feeling that in spite of more than 10 years practice in my city, even my city is having population more than 7 million. But awareness on recycling is very minimal. And the material available on recycling to have a water secure future is a major lacuna. So I want to hear experts on this, how to create public awareness and to have this material to facilitate public to create the awareness. This is a major challenge.
I'm thinking what you're saying, Neil. I'll leave it with you, but that the recycling is not keeping up with the
recycling, public awareness. Public is not aware about the benefits of the recycling of wastewater, how to use it, pricing, and what not. Singapore has done wonderful job on recycling and lots of things. But in India, we are facing this public awareness and availability of such material is a lacuna.
Perhaps if I can comment on the Singapore situation, there were two major elements, I think. Was the foresight of the Prime Minister, Lee Kuan Yew, that they should become independent of Malaysia for water supply. There were a couple of agreements, one expired in 2011, another one in 2061. So back in the 1990s, they embarked on the initial New Water campaign, and they brought in a lot of independent experts, a panel to verify that the process was safe. They had the politics. The Prime Minister at the time, Mr. Goh, was seen to be drinking New Water. And I remember visiting a shop and I said, "What do you think of New Water?" And the lady behind the counter said, "Well, our Prime Minister drinks it, so it must be okay." So I think there's a whole range of issues from the mayor or the governor of your province to set some leadership and demonstrate that it's okay. I'm happy to drink this because the science proves that it's safe. But as I mentioned, in both Singapore and Western Australia, there was an enormous amount of public consultation to persuade people that it was good. This is site visits, demonstration plants, try the water, and a lot of effort went into it. I think without that effort, it's very difficult because people don't know. Exactly as you say, the ignorance, well, I don't understand it, so if I vote no, we'll be safe. I think people have got to be convinced of the benefits of recycling, but it sort of starts with some political leadership as well. So if you want to do it, but your government doesn't care, it's pretty hard.
Look, there's 5 minutes left. There's only 5 minutes left. Dr. Sampat, we really appreciate you coming on board. Thanks for taking the time to do this. It's a crucial question. We're not talking small systems here, 7 million people in the but look, why don't we just take these last two questions? They're the top scoring questions on the Q&A panel right now. One from William Robinson in Arup in Sydney, one from Victor Brenners, and we'll fire away at them. What do you think? Do you think it's in the best interest of irrigators, farmers, for water allocation units in the Murray-Darling Basin to be decentralised, or for the government to take complete control given the present media attention on MDBA? Or is that too political?
Well, actually, I probably should hand all that through to John, because John has much more experience in that area and would certainly have a comment.
Your mic, John. Yeah.
The bottom line, I think, is that the community has to actually own the problem. And that is the example of our Indian comment just a moment ago. When the drought was on in Australia, the bellhops and taxi drivers actually owned the problem of a water shortage. Now they've forgotten about it again. And what I think is important is that you have to get ownership, and you are more likely to get ownership at the local level. But of course, you're also likely to get local political aggregation, you might say. But I think that you need to have a series of policies which are agreed between all of the governments involved, and then you leave the day-to-day management within that framework to people at the local level who know what's going on.
Yep, no, it's a good short answer, and they have to be short now. There's one more question left, which I have to ask. It's got a high score, and then we're going to have to leave it. There's another question that I'd love to get to, but not today, is the use of desal. Which countries use it better, and can developing countries afford this technology? If you've got a quick answer to that, we'll do it before we do this other big one, but maybe you can hear what I'm saying. Which countries manage the use of desal better than Australia, and can developing countries actually afford this? Is there a short answer, Neil?
Well, just very briefly, the Perth experience, I think they've managed it perhaps better than other areas of Australia, because they did have the problem longer. But it took them a long time to recognise that climate change meant that they could not rely on surface water anymore.
Yep.
But they were very cautious. It was under the leadership of Dr. Jim Gill at the time about whether to do it or not. And you'll remember there was a big decision on whether to plunder more resources from the lower Yarragadee Basin or desalination. And the government finally decided desalination, which I think was a very good decision. Affordability, well, the figures, it's, I think, worked out in Adelaide. If you had the desalination plant operating, it was equivalent to the cost of one glass of beer per week per household. Yeah. I think it's a matter of priorities. And many cases in developing countries, of course, there can be some foreign aid or assistance. But clearly the local ownership of the problem and the community wanting to solve their own problems and the governance to apply to it are key assets to encourage donors to come in.
Right, we're at 58 minutes, and Victor Brenners has asked from Department of Environment in Melbourne, in Victoria, what are the estimated life expectancies of desal plants? We'll make this the last question. For example, one that works at close to 100% like Kangaroo Island, and one that works ad hoc like in Sydney or Melbourne.
Well, the civil structures are normally designed for a life of 100 years. The mechanical equipment, such as pumps and normally 25 years, your control systems, PLC, computer control systems, normally 10 years, and you replace them. In South Australia, the desalination plant was replaced and upgraded to 400 kilolitres after 20 years of operation. But normally the membrane pressure vessels, the stainless steel pipe, the concrete infrastructure, the pumps, they just keep replacing as they reach the end of their life, and so the asset continues on. There are not many desalination plants that have been decommissioned. They've been operating since the 1950s, but the mechanical equipment and the pressure vessels and the membranes are generally replaced or upgraded. So that's a short answer to the question.
Yep. No, that's great. Look, thanks very much, gentlemen. Thanks very much, John, for staying on with us, and Neil, this whole time. There's a whole lot more questions here about balancing the demand for water and the supply of water, make sure demand side, supply side are balanced. Another few questions about energy, but the time is gone. We are absolutely out of time. Look, thanks for participating, everybody. There's a feedback survey coming up as soon as you close this window. There's a recording that will be mailed out to everybody. There's more webinars there and courses there coming up every week, as you can see. So I won't go into each one of those. Suffice it to say, we really appreciate your time today, Neil, and the incredible amount of work you've put into this, not just today, but in the 40 years of your work. Thanks for staying with us also, John, and commenting and supporting this webinar today. It's a great thing to be doing, this webinar. I wake up each day thinking, what can we do today? The best ideas in water, the best thought-provoking ideas. So we've probed a few today, and it's been great. Thank you, everyone, for joining us, Neil and John. Thank you. My team here have helped hugely. Couldn't do it without them. We'll look forward to seeing you next time, everyone. Thanks for joining us. Bye for now.
Subscribe to this YouTube channel by clicking the subscription button. For future webinars and online short courses, please visit our website at australianwaterschool.com.au.